Our current learning target is rate of change, and two terms that relate to rate of change are the independent and the dependent variable. The independent variable is the x value, or the input, or the domain, and the dependent variable is the y value, or the output, or the range. The y value depends on what the x value is doing. So for some of the examples we looked at yesterday, we had a rate of change of miles per gallon. The number of miles depended on how many gallons. One thing to keep in mind when you're looking at a word problem is if time is an option, it will always be the independent variable. Time keeps moving no matter what happens, so it is always independent of whatever else is going on. We're also going to be looking at different types of rate of change. Positive is when the values increase together. So this was an example when we looked at goals per game for a hockey team's offense. The number of goals increased as the number of games increased. You can have a negative rate of change when one value decreases and another increases. So this was like when Andrew was making milkshakes. The amount of milk went down as time went up. So that was a negative rate of change. And you can also have a zero rate of change when the dependent variable does not change. And we'll look at some examples of those throughout this lesson. First thing we're going to learn how to do is identify the difference between the independent and the dependent variable. So the question you want to ask yourself is, does A depend on B or does B depend on A? And whichever sentence makes sense, then you've figured out your dependent variable. So in our first example, we have pounds of apples costing money. So the two variables, the two things that can change, are pounds and money. So do the amount of pounds of apples you buy depend on how much money you pay? Or does how much money you pay depend on how many pounds of apples? The second sentence is the one that makes sense. So the money is the dependent variable, which means the pounds is the independent. So to calculate the rate of change, it is the change in the dependent variable over the change in the independent variable. So the change in cost, the cost went up from $3 to $9, so it went up. We had an increase of $6. The pounds went from 2 to 6, so we had an increase of 4 pounds. Simplifying, this gives us 3 halves, but when we put the label on it, we're talking about money per pound. So we would not say 3 halves dollars per pound. We would convert this to money, and the apples cost $1.50 per pound. Looking at our next example, an airplane ascended 3,000 feet in 10 minutes. So we've got the variables that are changing are feet and minutes. Minutes is an example of time, so we already know that this will be our independent variable, which makes the feet the dependent variable. And that makes sense because the altitude, or the feet, depends on how long the plane has been ascending. So to calculate our rate of change, change in dependent variable over change in independent variable. Well, our dependent variable went from 3,000 up to 4,500. That was an increase of 1,500 feet. And our time, or independent variable, went from 10 minutes up to 15 minutes for an increase of 5 minutes. Dividing, this gives us 300. Feet was the units for our dependent variable. Per minute, the units for our independent variable. Taking a look at one more. In January, the Johnson's heating bill was $100, and in April it was $50. So the values that were changing were the money and the time. We're talking about from January to April. So months, again, we don't have to ask ourselves the question because we've got time, always is the independent variable. And in this case, the money was the dependent variable. Calculating our rate of change, setting up change in the dependent variable over change in the independent variable. Our dependent variable, our money, went from 100 down to 50. So it was a decrease of $50 as the time went from January to April, up 4 months. Simplifying, we get negative 25 halves. But again, we're talking about money, dollars per month. So it does not make sense to leave your answer as a fraction. We don't talk about money in terms of fractions. We talk about it in terms of decimals. So it would be a negative $12.50 per month. And that makes sense. Your heating bill will go down as the months get warmer. So this one was an example of a negative rate of change. The other two we saw were both examples of positive rates of change. The more apples you buy, the more money you pay. And the longer the plane ascends, the higher in the air it goes. Next, we're going to take a look at determining positive, negative, or zero rate of change. So do the values increase together? Does one of them increase while the other decreases? Or does the dependent variable stay the same? So talking about tickets to Valley Fair, the more tickets you buy, the more money it costs. So this would be an example of a positive rate of change. In order to calculate our rate of change, we need to figure out what the independent and the dependent variables are. So the two values that are changing are money and number of tickets. So does the amount of money you pay depend on how many tickets you buy? Or does the number of tickets you buy depend on how much money you pay? The first sentence is the one that made sense this time. The amount of money depends on the number of tickets. So the money is our dependent variable, and the tickets is our independent variable. Calculating that rate of change, change in the dependent variable over the change in the independent variable. Our dependent variable, our money went from 30 up to 45 for a change of $15. It was an increase. And our tickets went from 2 to 3. So we were talking about a change of $15 per ticket. I bet most of you guys wish Valley Fair still costs $15 a ticket. Second example, we're talking about the late fee for a video rental. So $2 on the first day and $2 on the 7th day. First of all, we see day, that's time, so we know that's our independent variable. So notice that that money doesn't change. This is an example of a zero rate of change because the change in the dependent value is zero. You're paying $2 if it's late the first day, and you're paying $2 if it's late the second day. The change in our independent variable happened to be 6, still giving us a $0 per day change in the rate of change. Now in this case, the late fee would be cumulative. You're paying $2 per day, so by the end of 7 days, you're paying a total of $14, but the amount you pay each day stays the same. So that's how our rate of change is 0 on this one. Last one, we're talking about a house not being built on time. So the price paid to the builder is reduced by $50 after 2 days and $75 after 3 days. We've got time again, so we know this is our independent variable. And the money will be our dependent variable. This one, because the rate is being reduced, this is a key word, that tells us that our rate of change is negative. Change in the dependent variable over change in the independent variable gives us a change of 50 to 75 is $25, and from 2 days to 3 days is $1. Now the way we get a negative rate of change is we can look at this from the perspective of the builder. The builder is losing $25 per day for not finishing this house on time. Take a look at a couple of these U-Try questions, and we'll start with these as our warm-up tomorrow.